Okay. So, for starters, let's see. We need to open up our... We were running our server out of... Eclipse, but we were running our client from the command line, correct?
You can't run it in Eclipse, right?
You can run it in Eclipse.
Do they both run?
Yeah.
Do I want both of them to run?
You can run both of them in Eclipse.
All right.
Yeah.
All right, so this is the one to the far left is our server. The one to the far right. Okay. So for starters, let's clean up our client a little bit because we need to have this client a little bit more modular in order to work with the stuff that we're going to be working with. So we're going to go ahead and create another object on our client side. And let's create a new class. And let's call this guy what did I name the thing? Bits online? Bits file reader? Isn't that what I called it? Bits, B-I-T-Z. Alright, so bits file reader. And this guy is going to know how to read in a file. Okay? Now, remember, out here in our driver, we have this whole socket thing opening up a connection, the whole scanner from reading from it. Here's our ability to read in from the terminal. Here's the ability to write back out over the stream. We might be moving this guy. Then we're printing something out to the screen. Now, what we want to do is we want to start moving some of these guys into methods. And I'm going to start giving these some names because they are going to be helpful for us as we start addressing your problem. So what I'm going to do is I'm going to create a new class called Client Communication Protocol. All right, and client communication, what this guy is going to do is he's actually going to handle all the back and forth communication between the client and the server. Okay, so what does he need to work? Well, he's going to need that socket. And then we can set up all the rest of the stuff inside here. So we're going to go ahead and import java.net.socket. We'll make our constructor public. I hate when I make classes with that long of a name. Have our constructor for this, and this guy will take in a socket, the server, and we'll set this dot the server equal to the server. Okay. And then we're going to go ahead and have a method here, public void start communication. We'll just house everything in here. So we're just moving some lines of code around right now. We're not actually rewriting anything. We're just reorganizing. Okay? So when we build a client communication protocol object, we pass it the socket, and this guy does the rest. So what does it mean to start the communication? We go back out here to our driver. This is where we originally connect, and we get our socket S. I'm going to call this guy the server. Okay. Then we're going to create our instance of client communication protocol, CCP, is equal to a new client communication protocol, and I'm going to pass it the server. All right. Now all of this other crap, all this stuff we did before, I'm going to bring into, for right now, the start menu of our client communication. Okay. We really need this to be more modular because the path we're walking down here is eventually to do our own kind of BitTorrent thing, where what we were supposed to do for homework is have a file leave a client and arrive at the server and just write. So do what we did in class last time, which is clone locally, but now clone between potentially two machines. Okay, and assuming we finish before the end of class, we'll do that with one of you. I'll set up the server and somebody will share as long as it's not him. Somebody's got to have an appropriate image that they're going to share, and we'll see it actually transfer over to my machine. Okay, so here's our client communication protocol. What's this guy going to do? Well, he's going to set up the ability to read in from the server. So this is this dot the server dot get input stream, and instead of calling this guy input like we did before, we're going to call this let's see, what do we call it? Server input. Yeah, server input will work. Ability to read from the local client. So we have that as terminal input. So we name that guy reasonably. That's fine. Write to the server. So we're going to call this guy server output. And he's going to be reading in from this dot the server dot get output stream. All right. Then when we read in, actually, I'm going to do something here real quick. Just show you a quick little tool. So I just undid everything I just did. Still back to the input. I'm going to highlight input, right click on it, go to refactor, and go to rename. I'm going to call this guy server input. And notice it's changing in all the other places. Make sense how that worked? Okay, so that's refactoring. Do you guys talk about that in the software engineering class? Refactoring?
I don't know, but you've done it in previous classes.
Okay. Well, it's actually a software engineering concept. I was just more interested in whether that's something that, not necessarily bad or good, whether it gets covered in there. I was just interested in whether or not it got covered. All right, so I updated the name of that guy. So I'll do the same thing with my server output. So refactor, rename, server output. Okay. Similarly, right here where I say S, actually I wonder, I don't think that's a refactorable thing. That might just be a find and replace. So that's just broken code is what it is. I was hoping there was going to be a quick way for me to do that. So that's just this dot the server. So I'll just quickly copy that and okay, we'll come down to that stuff here in a second. Okay, and again, this guy potentially throws an exception, so I'll just say throws exception to get rid of some of these errors, except you can't do that at the top level there. You have to do it at the actual method. So this guy throws an exception. Okay, so start communication will give us the ability to read from the server, ability to read from the terminal, ability to write to the server, and then we already have the ability to write to the terminal. That's system.out.println, right? Okay. So right now we are reading something in from the server. So we are actually having a two-way communication going on right now between the server and the client, where a lot of this can actually happen here on the client side. So for instance, the stuff that we're currently reading in from the server, what do you want to do? When you first launch the client, when you first launch our client application, it's going to ask us, do you want to share a file or do you want to retrieve a file? Correct? For right now, everything we're doing is sharing from a client perspective. A client sending something to the server. So I don't even need to ask that question now. So what we're going to do is, let me actually go over to the server here. Here's the connected client on the server. So this is our thread that runs. So actually, is that true? It's a response thread. Response thread. Okay, what does this guy do when we run? It sends a message to the client. Do you want to share or download? Well, we're not even going to send that anymore. Okay. It's going to read in an answer, blah, blah, blah. Then it's going to send a message back to the server, to the client. So right now, we're going to have the server gutted. The server's not going to do anything right now. We're preparing it to put our code in there to receive a binary file, which is what's coming next. Okay? So I'll go back over to the client communication protocol. We're not going to read in from the server. Actually, I'm going to get rid of like a lot of this stuff. So we're just assuming we're sharing. So that's what I've updated here is all the code that was inside the if statement if they typed in share. I just took the if statement out and I've just highlighted it all in Command I for Mac and Control I for PC will indent it correctly. All right, so very first thing I'm going to do, I'm going to present to our client is we're going to get the current directories in the My Files directory that lives locally. So I know a couple of you asked me questions. You did have to create that My Files directory that we did in class because when I sent you the directory structure from, I didn't have all the folders created. I just gave you the Java code. All right, so you did have to create the / or you had to create the My Files directory inside of your source folder in order for this to work. So this is reading in that directory so that we can ultimately show a full list of the files that are in there, ask them which file do they want to share. That's this guy right here. We read in that answer. We were using a variable from above before. We don't have that variable anymore. So we'll read in the answer, whatever they typed in, and then we're going to spit out to them, you chose to share this particular file. Then we're going to go ahead and create a file object associated with that file. So we're going to say this is read the file from the client. Put a little comment in there. So here's the file object created with the file that they chose. Then we have our file input stream to read it in from the client. So this is just reading locally from the client into the from the client's machine into the client computer. And this is where we started doing the clone stuff where we were writing it out with the file output stream. Okay? And how did we write it out? Well, we used the file output stream to write, and we read in from our file input stream. This was reading it locally and writing it back out locally as a duplicate file. Okay, and that's where this clone came from. Right here. Our clone file. We're not going to have that guy this time around. We're not writing out to a clone file. That's going to be what lives over on the server. The server is going to be receiving a file. So the server is going to read from the socket and write out to the clone file. That makes sense? All right, so one of the things you were saying is you were trying to send is you wanted to send the file name and then potentially the size as well. So he wanted to send some information over to the server. So let's go ahead and go down that path. So right now I'm just going to comment out these lines. That way we can come back and grab them here in a little bit. That's the output stream. Okay, so right now all the client does is it assumes you're sharing, it gives you a list of the files in your directory, says which one do you want, and then it spits out this is the file you chose. Okay, and all it does then at the end that we don't see from the runtime of this is it has actually created a file object potentially available for reading through a file input stream. So now we're prepared to read in from the local file that they selected that they want to share. So now we want to start sending stuff to the server. That makes sense? So we need to send stuff to the server. How do we write to the server? We write to the server by saying server output. Okay, so server output. So we need to send something to the server. So right now, just to kind of get the ball rolling, we're going to say server output dot println. And what we're going to print is the name of the file. Okay? We're writing that out to the server. I'll put a little comment here saying, let the server know about the file we are about to send. About to send. All right. So we're going to communicate to that server. And in a minute here, we're going to start seeing the need for things like protocols. All right. So just connecting the dots here. This is all the client's going to do right now. Do a little dialogue with the local user, and then connect, then send that information to the server. What's the server going to do? That's in our response thread. This guy's just going to sit there, wait for the client to tell us the name of the file he is about to send. Okay? That's all that's going down in there. And actually, you know what? I'm thinking, when I said, can we run this in Eclipse, does Eclipse look in the source folder for that directory, or does it look in the bin folder for that directory? It did look in source, so my code worked in Eclipse. All right.
With some changes.
Well, it should have worked as is.
No, because the Windows path.
Oh, you write it a little different.
It's different. So
Okay.
It took some figuring out because you have to start at the source folder.
Got it. So wait for the client to tell us the name. So what we're going to do is we're going to just do a system.out.println. This is just going to be on the server side. And we're going to say this dot, the client dot, what do we call it, get or something?
Yeah, it was good message.
Get message. All right, so that'll read something in from the client. And that's getting a string message. That's not the get message you want to be using when you start reading in bytes. But this will let us kind of talk back in text between the client and the server. All right, so that's all we're going to do here on the server side. Is this line right here will block. And all the server is going to do is spit out to the screen the name of the file the client has proposed they are about to send. Okay? So I'll go ahead and, let's see, this is the client, right? Here, I'm going to put a big comment up here.
No, because
Client code.
then the server wasn't reading.
Since I
Reads the next line.
unfortunately called both my client and server driver.
Oh, please.
Okay, and this is driver code, or server code. Okay, so server code, client code. So I'll go ahead and I'll start our server up, start it listening. Okay, so that guy's waiting. Then I'll go over to our client, and we'll start this guy up. See, I don't think it looks in the same place. No such element exception. This is in,
Response to
oh, because it hasn't read anything in yet. Doesn't it block? Don't I have get message set up to block?
You don't have any client.
Huh?
You don't,
Yeah, this is the client here.
well, you didn't start.
Oh, I didn't start it. Thank you. CCP.start communication. All right. Server's still running. Well, we'll kill it. All right. Server started. Client start. You can see it's still not blocking.
what is the other? What does the client say? Because that was the server terminal. What was the client?
Where's the, how do I get to the client terminal? Up here? 132. Yeah, see, it doesn't know about that folder sitting in the source folder. It wants it in the bin directory.
So
Well,
apparently that was the entire time.
Yeah. Let's just do this the way I've been doing it, running the client from the terminal. Okay, it's too confusing. I think running two separate things, a client and server, both from Eclipse at the same time. And that is the problem. It wants that bin folder, or I'm sorry, the bin folder. It wants the My Files folder to be in the bin directory, not in the source directory, because right now I can't find it. So if I start the server in here, and then I go out and let me just get start my terminal up. CD there, and go to the client, right click, show in System Explorer, source. Okay, so now I have that, so I'll just say javac driver.java, Java driver. Okay. So now it's still doing that blocking problem up there, but we'll see what happens. So now it's asking me what file do I want to share. I'm going to say I want to share number 1. Do that. So it chose to share this, and then the idea is that it just sent that to the server. Server received. Dude, click that. Okay. The reality is we probably need to catch this exception, because what it's trying to do is it reads from the socket, recognizes that it can't, and throws an exception, even though it still is reading.
Did you restart the server?
Yeah, I did.
Okay.
I mean, it worked. This is a server. Server spit out the line that I sent it. Okay, so this is proving client read stuff in. We read stuff in from the client. The client then let us pick which file we wanted to send, got the name, sent it to the server, and said, ha, here's the file I'm going to send you. So we know now on the server side that we're going to have to create a local file called this. So we're cloning it on the server. Correct? All right, so what I'm going to do here is on the server, let's see, I think to do this, I'm going to do, well, let's just prove the point. Show in System Explorer. This is our server. Let me bring up this. And what I'm actually going to do is inside our server, I'm going to create a folder. This is in the bin directory of our server. Hopefully I'll be able to prove what I said before. And I'll call this guy My Files. Okay. So I just created a in the bin directory rather than the source directory, because I think Eclipse knows about this guy when it runs. Okay. So in our client communication protocol, we currently have the thing to create our clone file and our file output stream. That's fine. We'll grab that. Actually, we'll just do those two, one little step at a time. Now we're in our response thread of our server, so we know the file that's about to get sent, and it's in called get message, but I need to store that in a variable, so we're going to say string the file name is equal to this dot the client dot get message. All right, and we can print it out if we want. Let's say something like about to receive the file name. So I need to import java.io file for this. So we have our clone, which is going to be the local file. And actually, let's just call it the file. Let's call this the new file. Okay. The new file is going to be inside of /myfiles. We're not going to put clone on the front of it now. Why not? Well, because we have the name of the file name, and it's not going to conflict with what we had before, because what we had before was all in the same directory. This is in a directory on potentially another machine. All right, so the new file we're going to create is in /myfiles, the file name. And this should create a file locally for that. And then we have our file output stream. I have to import that from java.io. And this is the new file, not the clone now. All right, and this guy throws a exception. So again, I will throws exception. And then we need to deal with that out in our server driver, where we're spawning off our connected client. This is where it starts. Actually, hold on. Oh, you can't do that for a thread.
Mm-hmm.
So we're going to have to handle that internally. Well, that's fine. We'll try to do this. Catch, exception E. Do nothing because we're lazy right now. Okay. So, and actually we need to define this guy outside of here.
Finally block.
Finally what?
Use the finally block to close it.
Well, we don't need to do that. I mean, not yet, because we're not done using it yet. I mean, oh, you want to do more inside the try.
Well, I'm
You just did all your stuff in the try?
Well, I'm saying, like, I thought you were about to type close there.
Yeah, I get what you're saying. You want to do this fos.close here.
Yeah.
That can still throw an exception?
I mean, I didn't because of the word.
Right there.
Yeah, whatever.
We're not going to have a finally. We're just going to do all our stuff inside that try catch. All right, and for right now, this is our file output stream. We would write bytes out to this guy or something like that, but we're not actually going to write anything. We're just going to have it create the local file and prove that it's there and fill it with nothing. Okay? So this is again on our server side, so it's the response thread. So it's going to receive the name of the file that the client's proposing it's going to send. Then we'll write out, we're about to receive this file name. Then we're going to create a local file in the file system with that name. We're not checking currently whether there's already one. We'll just believe there's not one there right now. Create our file output stream. Try to write something out, even though we're not actually writing any bytes, and then ultimately close the file, which should save it to disk. So we should have an empty file on disk with the correct name on the server side. Fair enough. So I'll go ahead and kill our server, because we're going to restart it. Restart the server. Go out to the client. Nothing's changed on our client side. Just go ahead and run this. Number one, you chose to share this file. We chose to receive this file. Now what I want to do is go to this guy right here, which is the folder in our bin directory. Did he not get it? Is it in our source directory then? No. Do we actually have to write something out to it in order for it to save? Back to our client here. So I'm just going to write my favorite byte. Does anybody have a favorite byte? 127 is my favorite byte. So I'm going to write that out to the file and then close the file. If this isn't working, then this directory thing is not going to work within, well, I think there is a way to get it to work, but I'll take my server out to the terminal as well. Nah, I don't like the full path. I like relative paths. You think you're better than me? All right, waiting. Received.
About to receive.
That's right. This guy. Wait, hold on.
You're
That's a
binary.
binary tree.
What the heck are you doing in binary tree?
Oh, here's my. That's that one. That's in source. Should be in bin. Yep. All right. This will work better anyways. Here's my files. Go back once. Terminal. Create a second tab on my terminal. Can I name this guy? Server. Client. So we'll cd into the source folder there. And we'll do javac driver.java. We'll go ahead and run our server. Oh, I gotta stop it on Eclipse. Now we'll run our server. So it's waiting. I'll go to my client. We'll run this. I'll choose one. It should have written it back to the server. Here's this. So now if I go into source here and go into my files, we actually have a file with 1 byte in it. My favorite byte.
Open it.
See what that guy looks like. Maybe damaged. All right. No, you guys don't have a favorite byte? I totally opened myself up to. All right. So now we need to teach the client how to send it to the server. And how do we pull that off? So I have file input streams and I have file output streams. So locally on the two sides, on the client and server, I can read a file in a byte at a time, or multiple bytes at a time if I want to be more efficient. But right now we're just dealing with bytes. I can write stuff out 1 byte at a time on the server. But now I need to be able to send it over that socket. Let's just say for right now, 1 byte at a time. How do I pull that off? I need to write stuff to the socket. What options do I have for writing stuff to the socket?
So if you're talking client writing to the server right now, in the client you need to get, so if you're sending it, the output stream from the socket, and that's the stuff that you're gonna send it in that stream, write it to that stream.
Okay, and how do you write it to the stream directly?
I don't.
Okay. Well, let's look at output streams. Let's look at a generic output stream. So I'll do java.sun.com. I know that you guys probably have it bookmarked, but I'm above that. I'll go to java.io. And then let's just look at a generic output stream. A generic output stream lets me write bytes. And I can then also read bytes from a generic input stream. Well, how many bytes am I writing? So this is something you were trying to do. You were trying to tell your server how many bytes to expect, right? Well, let's add that. So we're going to kind of do this the old-fashioned way, 1 byte at a time. No harm, no foul. And we're going to see some issues. We're actually going to see why there's a need for TCP/IP. Okay. What am I doing? Oh, I need to be on the client. So the client is going to write something to the server. So that's going to be through the client communication protocol. So what am I writing? So this is how I write to the server, but that guy is a what? He's a print writer. Print writers teach us how to write. Print writers teach us how to write text. Okay, so this guy's a wrapper for an output stream which writes text. Instead, what I'm going to do, and we'll throw a something else up there in a few minutes. What I'm going to do is I'm going to say I'm going to start, actually before I even do that, let's do server output.println. I want to get my input stream, which I already have up here, fizz, and fizz.available. That'll tell me how big this guy is, which is the same thing as saying how many times do I have to read from the socket. We want to see how socket communication actually works. So I just did that over on the client. So the client's now saying, here's the file I'm about to send you, and this is how big it is. Okay, very proprietary protocol we're writing here. We're letting the server know a couple of things about what's about to happen. All right, so then on the server side, here's our about to receive. For right now, let me just comment out this code. That way I don't have to keep going deleting an empty file. Okay, we're about to receive, and then I'll also say system.out.println. Well, we'll call this the size, this dot the client dot get message. So we'll read in the size. I'll do this all in one line. So the file name, and then we'll concatenate onto that an open parenthesis concatenated with the size, concatenated with the string bytes, close parenthesis. Okay, so we're about to receive this file name, and this is how big it is. All right, so hopefully we can now send that information over to the client, and both of those things will be received. So I'll go back over here, kill off the server, recompile it, run it, server's waiting, recompile the client, run it, connecting, there's that. Server should have received it, about to receive this, and this is how many bytes. Okay, so now the server, at least on paper, knows how many times it needs to read from the client. Okay, we're going to try to do it that way first. So it needs to read from the client 45,626 times and write out to our file that many times. Okay. So we're back over here on the server. So we're going to create our new file. Already seen that. We have our file output stream. File output stream is going to be our new file output stream created around the new file. And we're going to write 1 byte at a time. Okay, 1 byte at a time. And we're not going to write my favorite byte over and over again.
You write my favorite byte?
Nope. All right, so right now we're just going to do it as a loop. So we're going to say, I'm going to change the size to an int is fine right now. And we'll say integer dot %, whatever they send us in the message. We're taking some liberties here, assuming the person's going to, the client and server are speaking the right lingo. We're not doing a whole lot of error checking here. Okay, so that's the number of bytes, so we'll catch it inside of an integer called the size. And then we'll have a loop down here. So for int I is equal to 0, I is less than the size, I plus plus. So each time through, what are we going to do? We're going to write something out. So after we create our file output stream, we need to write to it so many times. So that's fos.write. We're going to use the generic version of this. Okay, so we need to write a byte to this. And what byte are we writing? Well, we're going to be writing the byte we read in from the client. And what is that? That's, is the client a... So we need to read from the client. We need a read byte. So in our client connected client class, we have get message. Now we're going to add something called public. It actually is going to return an int. Read byte. Remember we talked about that last time, that unsigned bytes are actually represented as ints. So it's going to be read byte. And this guy's going to return this dot, the socket dot, get input stream dot read. All right, and it's, apparently this guy can throw an exception, which is fine because we have it inside of a try catch, so throws exception. So we're good with that. This is going to read exactly 1 byte, okay, from the input stream. So back out here in our response, actually back over here in, response thread, we'll say this dot, the client dot, read byte. So we're going to read the byte, we're going to write it out to the file. How many times are we going to do it? We're going to do it the size number of times. Make sense? All right. Now we need to make sure we write enough bytes over on the client side. So we're going to say the server side is in good shape. Oh, I still have my extra comment there at the bottom. So back over here on our, where am I? Where am I? I need to be protocol, this guy. So over here we have the number of bytes. So now we're going to say while fizz.available is greater than 0. Kind of the same thing we have, actually here we have this code. Well, we need to write differently. So now we need to write to that guy, and we have access to the socket here, the server. So I'll say this dot, the server dot, get output stream dot, write, and what are we going to write? We're going to write fizz dot read. Yep.
The fizz.available method, I don't think that it will return always the size of the file.
No, it doesn't return the size of the file. It returns the number of bytes that are left. We used it last time. What we want to see is whether the output stream, the generic output stream, works. So fizz.available says, it tells us, it gives us the estimate of the number of bytes remaining. So if we keep reading from it, every single time we say fizz.read, this guy should go down by 1.
Okay, but in the first, without, this line.
This guy here?
Yeah.
Well, we're writing it out to the server. This is us sending it to the server. And the server's receiving it, and we've seen that. Server got that number right here.
What I'm saying is that number might be wrong or not.
The short answer is yes, because it's estimated. It's advertised as being estimated. Punchline is you should never do it. We're doing it in a poor way by having a for loop running on a certain number of bytes. Okay, we're doing it in a bad way, but that's the number we have to work with right now. We're going to do it in a better way, okay? Because this is estimated. All right. So I'm going to finish up this real quick. All right, so keep writing as long as we have bytes. We're going to write a byte to from fizz.read. In the end, we can close fizz, but we don't have to, whatever. And the server, and then ultimately we'll say done on our end. And on the server side, I'll go ahead and copy this, and we'll do that on the server as well in a response thread. So I'll say done here as well, and the hope is that now we have a copied file. Okay, so I'm going to go over here, kill off the server, recompile it, run it, come in here, recompile, run, pick the file, says it's done, it sent everything over the socket. This guy says it's done, where it essentially said it read everything. And is this, this is our server, right? So here's my files, and there's my file. Make sense? So, I know we're in our last second here, but if somebody has a file they want to try to send to my server, it should work. We'll come back and we'll test it on Monday, but what we want to see there is that we were able to use the generic input and output stream as long as we're reading and writing 1 byte at a time. We can even send groups of bytes at a time. So when we look at file input streams and file output streams and buffered input streams, buffered readers, things like that, these guys are wrappers for the underlying kind of primitive type streams. All right, so we're going to come back next time. We'll try to make this a little bit more robust, maybe allow it to run a little bit quicker. We don't notice a speed problem with JPEGs, but if we start sharing movies, we might. Okay, so I will see everybody on Monday.